This program is an introduction to framing with residential steel. Whether your background is builder, framer, developer, or homeowner, the material covered in this video will give you an overview of the tools, fasteners, materials, and techniques used in steel-framed residential construction.
The advantages I've found from going from wood to steel are tremendous. We have found that the quality is very consistent. The members that we use are very straight, very rigid. Everything is still pre-cut, and so that it's still just as quick or quicker.
Building with steel is not a radical departure from conventional home building. Cold-form steel offers a variety of construction options, from stick-for-stick framing approaches to pre-engineered and panelized systems. Steel also offers the option of being used along with more traditional building materials. Many builders using steel for the first time will frame their interior non-load-bearing walls with steel, and later, once they're more familiar with the material, advance to houses entirely framed in steel. Regardless of which approach you use, you first need to draw up a materials list based on engineered drawings. Design services can be obtained from some manufacturers or from independent consultants. Be sure to closely review the details of your plan with a structural engineer to ensure structural integrity and efficient use of materials. With materials list in hand, steel can be obtained through numerous suppliers, including steel framing manufacturers, commercial building suppliers, and many home improvement centers. Cold-form steel comes in a wide assortment of pre-cut widths, lengths, thicknesses, and shapes. Many suppliers can deliver standardized steel components that are specifically engineered for different framing needs. The steel you order through a supplier can be cut to length and delivered to the job site, which can save you considerable time, or delivered in stock length and cut by you to meet specific job needs.
Out here on this job, we had wood framers that converted over to steel framers. Their biggest adjustment was in the tools, going from saws, electric saws, to drill guns and cut-off saws. And once they made the adjustment in 2 or 3 weeks, they were just as fast as they were with the power tools before.
Retooling your crew for steel-framed construction does not involve long periods of training or expensive purchases. The actual tools you will use with cold-form steel are all off-the-shelf items, affordable and easy to work with. As with any construction job, these tools must be selected following manufacturer's recommendations. A screw gun is used for most fastening work. Screw guns are lightweight, reversible, can be set to variable speeds, and accept a variety of different screw types. For cutting steel, a 14-inch chop saw with metal cutting blade is recommended for quick and efficient work. A pair of tin or aviation snips are essential for any on-the-spot shearing and trimming work of lighter steel. Assorted clamps are helpful for holding steel studs and joists in place during fastening. The rules of safety on a steel-framed construction site are generally the same as in traditional building. Till you're comfortable handling cold-form steel, it is recommended that you or your workers use a pair of lightweight gloves to protect hands from the possibility of small cuts and abrasions. Standard construction goggles and earplugs should be used when cutting or grinding steel. And, where appropriate, hard hats should be worn by crew members. Steel framing uses an assortment of off-the-shelf fasteners. Self-drilling screws are the most common. These screws come in a wide range of styles for different job requirements. Generally, screws should be approximately 3/8 of an inch to 1/2 inch longer than the connecting material's thickness. A minimum of 3 exposed threads should extend through the steel to assure adequate connection. But these are minimum guidelines, It is important to select the correct fastener for each application. Consult the manufacturer's specifications for correct type and length. Powder-driven pins are widely used in attaching steel track to concrete slabs and foundation. The holding strength of these pins will depend on shank diameter, depth of penetration, and spacing and edge conditions. Bolts and anchors are also commonly used to secure steel framing to masonry, concrete, and to other steel components. Finally, in some cases, welding can be used for joining connections.
Got a lot of advantages, and one of the biggest things for us is that the material is very stable. When we build a project or a house, everything stays very straight. We don't have any warping or twisting, and that's one of the most important features for us.
Steel framing is used on any type of foundation, slab on grade, crawl space, or basement. In a slab on grade foundation, a bottom track, comparable to the sill plate in traditionally framed homes, is bolted along the top of the slab on grade and secured with anchor bolts, expansion anchors, or powder-actuated fasteners to the underlying foundation, with fastener spacing installed as recommended by your engineer. In the case of crawl space or basement foundations, horizontal steel joists are attached to the foundation with anchor bolts, and a track is screwed into the joists using hex or panhead screws at appropriate intervals. Consult your manufacturer's specifications in choosing which bolts or fasteners and their exact spacing, design, and edge requirements. Laying down the joist framework for subflooring on top of basement or crawl space foundations follows traditional building techniques. Lightweight steel floor joists, typically spaced at 24 inches on center, are attached to the header beams or track with hex or panhead screws and standard plate connections. Unless design considerations demand otherwise, lapped joists are unnecessary in many multiple span conditions. A single length of joist is commonly used to span continuously, with savings in construction time and materials. At the subflooring stage, steel joists support load-bearing walls in one of two ways. A heavier steel than what is used for non-load-bearing walls is appropriate for those sections of flooring absorbing greater loads. This would replace the double joist approach typical in traditional construction. However, there is nothing preventing a builder from using double joists or bridging for load-bearing wall sections. This may consist of blocking, flat stripping, or a proprietary system. With the floor joist framework in place, standard subflooring is attached to the joists using flathead or bugle head screws. Subflooring material, plywood, wafer board, or oriented strand board, is applied using standard industry adhesive. In addition to the stick-for-stick approach, pre-engineered and component prefabricated steel systems offer the advantage of pre-building part or entire sections of the floor system at the manufacturer's site for delivery and quick installation.
I didn't like the idea that you either had to go wood or nothing at all. And so now that we were experienced with it, I think we'd be foolish to go back to wood, considering it's less expensive. It's 100% recycled steel. It doesn't burn, so you don't have a problem with that. You don't have a problem with termites.
Steel provides a builder with three options for wall construction: the stick-for-stick approach, a pre-engineered system with wall components already built and delivered to the site, and a panelized approach with sections of a wall ready for installation. As in traditional building, it is common practice to first assemble the steel-framed walls in sections on the ground or in a factory, tilt them into place, and then secure them to the floor. For load-bearing walls, a structural C-shaped stud is generally used. These studs are available in sizes from 2.5 to 12 inches. Drywall metal studs for non-load-bearing walls range in sizes from 1 5/8 to 6 inches. Standard length studs are available pre-cut for ease of installation by framers and for use by subcontractors. If studs need additional hole punching on site, A drill with an appropriate bit size can be used to create the necessary stud holes. Hole diameters can be up to 2.5 inches, but should not exceed half the depth of the structural member. Contractors and builders should verify with engineering professionals the size and location of openings. Pre-cut studs are arranged between a top and bottom track, similar to the sill and top plate in traditional framing. It is recommended that a sealer be provided between the foundation and track to create a thermal break and act as a moisture barrier. In a stick-for-stick approach, spacing of studs ranges from 16 inches to 24 inches on center, depending on drywall requirements. Panelized and modular systems are generally engineered to require fewer studs. Once in place, studs are screwed to the track flange with panhead screws at appropriate intervals. Only one stud is usually needed for structural purposes at each corner of the wall frame. But typically, the inside corner will require an extra stud to facilitate drywall attachment. The track is then screwed to the floor joists using panhead screws. Wall corners are connected by screwing corner studs to each other. Headers for windows and doors are easy and economical using steel. A header beam is created by doubling up standard joist material for reinforcement. Further reinforcement is secured through additional members at the jamb and at the window head. This same approach is used for door headers. At the base, the door jamb, consisting of multiple stud members, is attached to the track with anchor bolts. Wall sheathing may be installed while a steel-framed wall is on the ground or in a vertical position. Sheathing is attached to the studs using flathead or bugle-type screw connections.
We talked with a number of steel suppliers and installers and discovered that we could save time and money, as well as get all the benefits that we already knew about with steel framing as stronger in earthquakes and stronger from a vertical load standpoint.
Steel framing can be used for any roof system, from a stick-for-stick rafter and joist approach to systems accommodating cathedral and other non-standard designs. The required tools and fasteners are no different than those used in steel floor and wall sections. Many steel-framed homes are built with truss systems for reasons of cost, speed, and efficiency. Trusses can be ordered to meet specific design requirements and delivered to the site pre-assembled or in pre-cut pieces to be assembled on site. If in pieces, it is typical for a roof truss to be first assembled on the ground before being lifted into place. As with any truss, the number, size, and thickness of the web members will be determined by the engineering requirements of the roof span. However, steel offers the advantage, in many cases, of requiring fewer members for any given span due to its strength and durability. The appropriate number of web members are attached to the truss frame with panhead or hex washerhead screws at connecting points. Generally, steel trusses are lighter than conventional trusses. No special equipment is needed to lift the truss into position. Depending on the height of the roof, a truss can be hauled or simply lifted up. Steel trusses are spaced anywhere from 16 to 24 inches on center, depending on design and load requirements. There are systems engineered for greater span distances, often resulting in a shorter production schedule and increased savings. Bridging, if needed, is attached with panhead screws. Additional bridging, double joists, and clip angle attachments are normally required for those roof systems that involve gable dormers, chimney openings, and other design and load-bearing considerations. Standard industry sheathing materials such as plywood or flakeboard can be applied to a steel-framed roof. Sheathing thickness will depend on the truss spacing. Sheathing is attached with flat or buglehead screws to the underlying truss sections. Any type of window can be used with a steel frame, a single or double hung, fixed or awning. First, the window unit is placed into the rough frame opening, level and plumb. Once secure, flat or bugle head screws are driven through casing and wedge points into the track and head. Steel accepts any kind of door on the market, flush or panel, wood or metal skin. The door unit is placed into the rough frame opening. Often, a temporary brace helps while the door is centered and secured. Then, pan or hex washer head screws are driven through the two side jambs near the bottom of the frame. Additional screws are added where needed.
Well, the first couple weeks were kind of tough, just basically understanding what we were doing with the metal and learning the different gauges and the different tools. But being your basic tradesman, you're working with tools all the time, so you just adjust to the different tools you use.
For subcontractors, working with steel is easy due to the speed and convenience of pre-punched steel studs. Tools used by subs are basically the same used in traditional framing, with adjustments made for steel hole punching and screwing. Plumbing, electrical, and ductwork installation is quick and straightforward. Applying drywall to interior studs involves no special tools or techniques. Each standard drywall plank is screwed into a truss, joist, or stud using appropriate length, low-profile, or bugle head screws. Because steel does not warp, a builder need not worry about drywall bowing or fasteners popping. Finally, insulation poses no complicated installation requirements in steel-framed homes. Copper piping, because it reacts with galvanized steel, needs to be wrapped in insulation. Studs, joists, and ceiling areas can easily accept blown or semi-rigid board insulation as thermal needs dictate. It is recommended that full-width batt insulation be placed in all jambs, headers, and build-up members, as well as between framing members in areas that separate climate-controlled spaces from the exterior. The use of a thermal break or rigid insulation on exterior framing can also result in significantly better thermal performance.
Our floors are perfectly level. Our walls are perfectly straight. Our drywall hangs, of course, very flush and true. We don't have the nail pops that we did before because we use screws now. We can do away with the glue altogether. We don't have the glue, so we speed up our production there. We don't have squeaks in our floors anymore.
When complete, steel-framed homes are indistinguishable from traditionally framed homes. Finishings, decoration, balconies, and other design aspects look the same as in traditional houses. But the advantages are there to be seen. In straight walls, in the assurance of no warping or rusting, in the structural integrity that eliminates termites and ensures better protection against earthquake and hurricane forces. Framing in steel results in a house with potentially fewer callbacks, and that translates into increased profits for the builder or developer.
As we started to come out of the learning curve, we picked up our pace to where the second 12 houses we did went, I would say, twice as fast as the first 12.
The values that we're getting structurally are much higher than